Hi everyone, in previous classes we have studied about the energies of orbitals. The energies of orbitals are different in a single electron system and the energies of orbitals are different in multi-electron system. In today's class I wish to discuss with you the filling of an orbitals by the electrons in that different energy levels, how the electrons fills one by one. By the help of some rules we conclude or we know the filling of that orbitals by the electron here. So first I wish to discuss with you Aufbau principle. Would you know the meaning of this Aufbau principle or what states this Aufbau principles to us? First I wish to say the meaning of Aufbau. In German word, Aufbau means a building up of orbitals by the electron. So Aufbau principle states that here in a ground state of the atoms, the orbitals are filled in a order of their increasing energies. Orbitals are filled in order of their increasing energies. So see here, so this is a energy level. So this is a one orbital which available to these electrons. They are filled first this orbital. And next they filled another orbital which have a greater energy level than this orbital. Only when completely the first orbital, first one some amount of an energy level, this orbital have a some amount of an energy. So this is a lower energy level and this is the higher energy level and this is again higher energy level and this is having again higher energy level. So this is a lower energy level of orbital. First the electrons are filled, which lower energy is available for that. So when this lower energy level completely filled, then only when this lower energy level is completely filled, then only the electrons are filled next energy level. And when this energy level is filled and next they filled this energy level. So see here, the orbitals are filled. These are different orbitals. They are increasing their energy levels. They are in this order which are increase their energy levels. So in the ground state of the atoms, the orbitals are filled in the order of their increasing energies. Filled. They are filled. First filled a lower energy level and next filled the higher energy level than the first orbital. And next third orbital is filled then the second orbital. And this fourth energy level is filled by the electron then when only the third energy level is completely filled. So like this the electrons are filled there, electrons are filled orbitals, their increasing energies in the order of their increasing energies. So this is what principle above principle says to us. So see here, these are our energy levels. I wish to write here, let me write here 1s, 2s, 3s, 4s, 5s, 6s and 7s and 2p, 3p, 4p, 5p, 6p, 7p and next 3d, 4d, 5d, 6d and next 4f and 5f. Let's move in this direction. First fills 1s orbital and next second fills a 2s orbital and next we are having greater energy levels 2p and 3s orbital and next 3p and 4s orbital. Next 3d and 4p, 4p and 5s orbitals and next 4d, 5p, 6s orbital. So like this, in this manner, first filled 1s orbital and next 2s and next 2p, next 2p and next energy level is 3s, and next energy level is 3p, and next energy level is 4s. So like this. So I wish to explain by the example. In a lithium we are having 3 electrons. So I filled 1 s2. So this orbital filled completely. Then only we move a 2s 1. So totally we are having 3 electrons here. So like this, the electrons are filled their orbitals only in the order of their increasing energies. 2s orbital have a greater energy than 1s. 2p orbital have a greater energy than 2s. 3s orbital have a greater energy than 2p. So like this, first electrons fill in a 1s. When 1s is completely filled, then only the electrons filled in the 2s orbital. When 2s orbital is filled, then only the electrons are filled their higher energy level, that is in a 2p. When 2p is filled, next the electrons are filled in a 3p, and next the energies are 3s. Next the energies are filled in a 3p. So like this, the electrons are filled their orbitals filled in the order of their increasing energies. Just remember this point, order of their increasing energies. So these are the orbitals. So I write here these orbitals in their increasing level. First electrons are filled one orbital. When it completely filled, then next electron filled in a next energy level of the orbital. So this is all about the Aufbau principle. The next one is Hund's rule of maximum multiplicity. I wish to explain this rule by one example. Let me explain one example here. So this is our oxygen atom having atomic number 8. Means it has 8 electrons in atom. I wish to configure these electron like this: 1s2, 2s2, 2p4. Just add these electrons: 2 plus 2 4, 4 plus 4 8. Totally I configure 8 electrons like this. I fill these electrons with the help of Aufbau principle. So what Aufbau principle states that? Aufbau principle states us the electrons are filled in an orbital with increasing their energy level, with the order of increasing their energy level. So 1s orbital is less energy. 1s orbital has a less energy than the 2s orbital, and the 2s orbital have a less energy than the 2p orbital. So according to the Aufbau principle, I fill these electrons with respect to their energy levels, with increasing order of their energy levels. And next, what Hund's rule states us. So see here, I wish to draw the orbitals. So this is a 1s orbital, this is a 2s orbital. Already you know that in the p-shaped shell we are having 3p orbitals like px orbital, py orbital and the pz orbital. So next, how these 2 electrons are filled in this one orbital. How these 2 electrons are filled in this 2s orbital, and how 4 electrons are distributed or accumulate in these 3 orbitals. So this states, we got this answer by the help of Hund's rule. So Hund's rule states us how these 2 electrons filled in or accumulate in a 1s orbital, 2 electrons filled in 2s orbital, and 4 electrons are filled in this 3 orbital. So see here what Hund's rule states us: the pairing of electrons in the orbitals belonging to the same subshell like a PDF. So these PDF orbitals are, subshells are called as degenerative states. Means the different orbitals orbitals present in same energy level. So these orbitals are called as degenerate orbitals. P is a degenerative orbitals, D is degenerate orbitals, and F also has a degenerate orbitals. Because in the P subshell, in the same energy we have a 3 orbitals. So like in the D subshell we have a 5 orbitals. So like these degenerate orbitals or the orbitals present in the same subshells P, D, F, see here, the pairing of electrons in the orbitals belonging to the same subshell P, D, F does not takes place until each orbital belonging to that subshell has got a 1 electron each. So what he says is, I start to fill the electrons in these orbitals. In a 1s orbital we are having a 2 electrons, 1, 2. In a 2s orbital we are having a 2 electrons. I fill 2 electrons here, 1 and 2. And then what about next p orbital? Can I fill the orbitals like this? 1, 2, 3, 4. No, this is a wrong method. Or can I fill the orbitals like this? 1, 2, 3, 4. No, this is also wrong method. Just observe the statement, means above statement. I fill the electrons like this, 1, 2, 3, next one is 4. So this is a right method to fill the electrons. Electrons are accumulated or to fill these orbital like this. So see here what the statement says. Once again I wish to read the pairing of an electrons. So see here, the pairing of an electrons in the orbitals belonging to the same subshell P, D, F does not takes place until each orbital belonging to that subshell has got a 1 electron. First, these subshell filled by 1, 1 electron with the same spin. 1, 1 electron with the same spin, and next the pairing will be start here. So this states by Hood. So see here, if I fill electrons like this, 1, 2, 3, then 4. So see here, we are having a different spin. When I accommodate a single electrons in these orbitals, these are having a different spin. This is a downward direction and this is a upward direction. This is also a wrong method to fill the electrons. So there must be these singly filled electrons have the same spin. So these are all in a upward direction having a same spin. So this is a right method, and then the pairing will be starts. This electron is in downward direction. Now the spin will be changes here, and next all electrons are filled only in this downward direction only. So see, I wish to explain by another examples like a D or D5 orbitals, D6 and D7. We are having the subshell, D subshell, having a 5 orbitals, here, 1, 2, 3, 4 and 5. We are having a totally 5 electrons in this subshell. So see here how I fill 1, 2, 3, 4, 5. Is this correct method? No. Why? This is having a different spin. So what the condition in the Hund's rule? these filling electrons, these first singly filling electrons are in a same spin, means in a same direction. So I fill like this. So this is the correct method to fill the electron. And next we are having a D6, means 5 orbitals, 1, 2, 3, 4, 5. Totally we are having a 6 electrons. First I wish to fill 1, 2, 3, 4, 5. Totally first I fill 5 electrons singly, and next the pairing will be starts here. 1. So how many electrons are filled? 1, 2, 3, 4, 5, 6. Totally 6 electrons. So this is the right method to filling the electron according to the Hund's. And next the 7, D7. 1, 2, 3, 4, 5. Start to fill with me. Start to fill these electrons with me. 1, 2, 3, 4, 5. And next the pairing will be starts. 6, 7. So this is the right method to fill the electron or to accommodate the electron in its orbital. So this is all about Hund's rule of maximum multiplicity. I hope you got the clearance about this Hund's rule. I wish to explain once again. The pairing of electrons in the orbitals belonging to the same subshell. So this Hund's rule says about these orbitals like P, D, F does not take place until each orbital belonging to this subshell has got 1 electron each, means it is singly occupied. First these orbitals are filled by singly occupied electrons, and then next starts the pairing like this. Pauli exclusion principle. So this principle states as no 2 electrons in an atom can have the same set of 4 quantum numbers. So see here, already you know that about this set of quantum numbers. We are having a totally 4 quantum numbers, like principal quantum number N, and next one is azimuthal quantum number L, magnetic quantum number ML, spin quantum number MS or S. So we are having these 4 set of quantum numbers. These gives an address of an electron. I wish to take one example. Consider it is our lithium atom. In this lithium atom we are having 3 electrons. This atomic number is 3. I wish to configure these 3 electrons like 1s2 and 2s1. And I fill these electrons in their orbitals. This is our 1s orbital and this is our 2s orbital. So 1s2 means 1, 2. I fill 2 electrons, and here I fill 1 electron. And next I wish to give the values of quantum number to this electron. Consider this electron. Consider this electron, the electron which is having in an upward direction. Consider that electron. I wish to write the values of quantum number to this electron. So this is our 1s orbital, and having a n value is equals to 1. And next L value is equals to S means 0. Already you know that the principal quantum number says about the main shell, and here the values are 1, 2, 3, 4, and here L start from 0, 1, 2, 3 means S, P, D, F, and ML start from 0, 0, minus L, 0, plus L or plus L, 0, minus L, like this. Means here consider spin quantum number, positive half and negative half. So these are our value of this quantum number. Next, come here. I wish to write the quantum numbers values belonging this electron. So n is equals to 1 because its main shell is 1 shell, and next L is equals to, it has a subshell S, L is equals to zeros. L is equals to 0. Then the magnetic quantum number is ML is equals to 0, and next S is equals to, consider if the electron is in upward direction, its value is plus half, or it is in downward direction, its value is minus half. So these are the 4 values of quantum numbers belonging this electron. In this 1s orbital, we have 2 electrons. So I write the values for this electron only, and next I write the values of this electron, means this electron. I write the values of this electron. This is also belonging to the 1s orbital, means n is equals to 1 and s is equals to 0 and L is equals to 0, but spin quantum number, this is a downward in direction, but the spin quantum number is minus half. So observe here, principal quantum number is same, azimuthal quantum number is same, and magnetic quantum number is same, but the spin quantum number is different. So this states a Pauli's exclusion principle. So see here, no 2 electrons. These are the 2 electrons in an atom. In this atom only, in this lithium atom, we are having these 2 electrons. They are same in 3 quantum numbers but differ in 1 quantum number. So no 2 electrons in an atom can have the same set of 4 quantum numbers. Same set of 4 quantum numbers. So see here, I wish to write quantum number values for, I wish to write once again here. So this is our 1s orbital. So this is 2 electrons and this is our 2s orbital. We are having 1 electron. I wish to write the quantum number values for this electron and for this electron, and just I wish to start to write n is equals to 1, just write these values, L is equals to 0, ML is equals to 0, and next S is equals to positive half, and next write the 4 quantum numbers to this electron. N is equals to 2 because it is a 2s. Then L is equals to 0, S means 0, and ML is equals to magnetic quantum number also 0. S is equals to, this is also in a upward direction, so this is also a plus half only. So just observe here, spin quantum number same, magnetic quantum number same, azimuthal quantum number same, but the principal quantum number not same. They are different. Here also these 2 electrons are similar values in 3 set of quantum number, but in a 1 quantum number they are not similar. They are not similar. So I wish to say once again this statement, no 2 electrons in an atom can have the same set of 4 quantum numbers. Or you can write, or this Pauli exclusion principle can also states that only 2 electrons may exist in the same orbital. So this is a 1s orbital. So here only how many electrons can exist? How many electrons can accommodate in this 1s orbital? Only 2 electrons can exist in the same orbital, and these electrons must have a opposite spin, means the spin quantum number is changed here. So observe here, only two electrons can exist, only two electrons can exist in a same orbital. They have a 3 quantum number values are same, but they are arranged in different spin. They have different spin, like plus half and minus half. So this statement also state by this Pauli's exclusion principle. So according to these rules, like Bohr rule and Hund's rule and this Pauli's exclusion principle, these rules are state how the electrons are filled in their orbitals. In our next class, I wish to come with the electronic configuration. How